An insurance company insures a large number of drivers. Let X be the random variable representing the company's losses under collision insurance, and Y represent the losses under liability insurance. X and Y have a joint density function here. Calculate the probability the total company loss is at least 1. So the total loss will be X plus Y, because X is one kind of loss and Y is the other kind of loss. So the total loss will be the sum of the two. And we want that probability to be at least 1, which means greater than equal to 1. Now, it's a bit easier. The double integration is a bit easier if you do the complement, the X plus Y less than 1. So that's what we will do. The whole region is 0 to 1 for the X and 0 to 2 for the Y. So that's the outer rectangle. See, 0 to 1 for X and 0 to 2 for Y. And the complement of this X plus Y greater than equal to 1 is X plus Y is less than 1. So this is the line X plus Y equals to 1, assuming that this point is 1 over here. And so this triangular region is what we will be using for integration, and then take the complement. So probability X plus Y less than 1, as we said, we'll do it over the complement region. So that will be, so again, we are doing with respect to Y first. So with respect to Y means you take a vertical strip. So on the lower end of the strip, the Y will be 0. And at the upper end of the strip, the Y will be 1 minus X, because this is the line Y equals 1 minus X. So Y equals 0 to 1 minus X. And X goes from here to here, 0 to 1. And then when you integrate this, I pull the 1/4 out, and the 2x plus y is a constant. So the integration of this with respect to y is just 2x plus y times 2x plus 2 is a constant. So integration of that with respect to y is just 2x plus 2 times y. And the integral of y is y squared by 2. And y goes from 0 to 1 minus x. And when you substitute 1 minus x for y, you get this, and the lower limit is 0. Both terms will be 0 because y is 0 as a product. And then when I multiply this out, I get these two multiplied to give me 2 minus 2x squared. And here, when I open the square, that's 1 minus 2x plus x squared. And then when I divide by 2, it splits up like this. And I also have a negative outside. So negative half plus x minus x squared by 2. And then when I do the algebra on all this, I get 3 halves plus x minus 5x squared by 2. And now it's very easy to integrate. This is just 3x by 2 plus x squared by 2 minus 5x cubed by 6. And 0 to 1. And so you see, the reason why we did the integration of the complement region is that for both the integrals, this inner one as well as outside one, the lower limit was 0, which will not be the case if you do it directly with with this region. That you can even see from the figure that this white region is the more complicated region. So that's what you will be doing if you were to do it directly, whereas this blue region clearly is a simpler region. So after doing it, I get 7 by 24, but that was for x plus y less than 1, and I want x plus y bigger than equal to 1, so that's 1 minus x plus y less than 1, 1 minus 7 by 24, that's 0.71. That is choice D.